Greetings and welcome to my new calculus channel. My name is John Gabriel, and today I'm going to talk about what is a rate. And I've had a discussion with Gemini or Bard, which is like speaking to a mainstream math professor. So I begin by saying rate of change is a bunch of crock, and if you call 3x squared, which is a derivative of x cubed, a rate of change, then x cubed is also a rate of change, and every function is a rate of change. So it's not only very misleading, but wrong to call a function a rate of change because nothing is changing. And so this discussion with ChatGPT is exactly about that. Okay. And so ChatGPT says, understand your frustration. Well, I'm not frustrated, but in any case, so it goes on trying to say that a rate of change is essentially a measure of how one quantity changes in relation to another. Now, that's not true because um, in physics we use time as one of the quantities. Okay, and there we can say that something changes according to time or doesn't change but is actually in proportion. So this rate of change should rather be is in proportion. A rate is something that is in proportion to something else. So for example, if you have a graph of distance to time, then you're looking at how distance is in proportion to time. Okay, but of course nothing changes on the graph, so it's not a rate of change. But of course, if you're talking about something with respect to time, you think of it as a rate because you think, well, something has gone from this distance to that distance in so much time. But is it really a change? Because look, when you calculate, for example, velocity, you have S final minus S initial over the time final minus the time initial. These are differences, okay? So they're not actually changes, they're differences. Now, you might say, well, if you're driving a car, these change randomly. But in a function, these do not change randomly. They're all fixed, okay? Nothing is changing in a function. So if you're looking at the tangent lines, they're all fixed. Nothing's changing, okay? And when you apply this sort of scenario to a function like that, it's just a model. The function's not changing, right? And it's misleading to say ds dt in that sense, okay? Because ds dt is just simply the slope of a tangent line and nothing else, by the way. There's no change taking place. There's nothing instantaneous happening, no rate of change, zilch, okay? And in reality, when you're driving a car, you don't even use calculus. There's no use of calculus to calculate your speed. That's just drivel that you hear from idiots who've never understood mathematics or calculus. So let's go back to this discussion. So the derivative, it says, in this case, represents the instantaneous rate of change. That's absolute rubbish. And so then it comes back with this analogy of a car's distance traveled over time. And I've just shown you now that that's not the case in reality. It's only the case when you apply or when you consider a model to be reality, which is rarely ever the case, by the way. So in physics, that is. So again, I'm busy going back and forth here with ChatGPT, and it says, you're right, the function itself does not change. It's a static mathematical object that defines a relationship between inputs and outputs. The inputs and outputs don't change, right? And I mentioned that to GPT. I said the output does not change in relation to the input. Okay, the ordered pairs have been the same in past perpetuity, are the same now, and shall continue to be the same indefinitely. So a function itself is a static entity, as GPT, I'm sorry, as BARD. I've been saying GPT, but this is BARD. As BARD response, it says a function itself is a static entity, and the set of ordered pairs that define it is fixed. But then again, it tries once again to define the concept of the rate of change. And it says how the output values change. Well, they don't change. The differences change. That even the differences don't change, but the differences are different. I mean, to state the obvious, it's kind of stupid, isn't it? And so then it says if we take the function x squared, the function itself, the rule that squares the input is fixed. Of course it is. So, and again, I tell Bard that you get different values because the square of that which is input differs, but that doesn't mean anything changes. The inputs and the outputs are always the same and nothing is changing. And then finally it says um, uh, that there's some kind of dynamic behavior. So it tries to validate it by saying, while the function is static, the dynamic behavior we observe, you don't observe that in mathematics. You observe that only in physics. Like, for example, when you're driving a car or you're flying an airplane or you're taking the pressure of some application, etc. Okay, but not in mathematics. You're dealing with the model in mathematics. The model doesn't change. There's no dynamic behavior. X squared has the same unchanging properties. So finally, Bard reaches a correct conclusion, and it says, it seems we've reached a common understanding on this point. I somehow doubt that because Bard cannot understand anything, it cannot think, etc. So my response is that it's a sum total of the idiots who created it. Now, what I'd like to present to you, but before I do that, it's a brilliant article, by the way, but before I do that, I want to talk about what happens when you search for what is a rate in mathematics. So you come up with something like this. And this site says, the first site says, when two quantities of different units, well, they don't even have to be different units. Any number is a result of a rate. Okay. So if you look at this thing here, where all these line segments are equal, the result of this ratio, the measure, is the number 2, which is a rate. Okay. And you can also look at it as being the count of these line segments, where you've predefined 1 to be the measure of that, 2 to be the measure of that, 3 to be the measure of that, etc. Okay? So every number, in effect, comes from rate. And then it gives you the same example. If we say that a car travels at 100 miles per hour, then it means in 1 hour it covers 100 miles. So when we think of time, that's normally when we think of a rate. But this ds dt has nothing to do with anything that changes. It's always the slope of a tangent line, okay? Nothing is changing. That's all that ds dt means in this for. So ds dt in the case of y is equal to x cubed is just simply 2x, okay? So that would be ds dt, right? ds dt. Now, remember again, this is just a model, right? So nothing is changing in the model. Absolutely nothing. And generally, these models don't represent physical systems exactly. They're only estimates. And of course, calculus is both null and void unless you have smooth functions. So, and it tries to, this article here, this website tries to make the case that they need to be different units. Well, the most important thing is that one of them is a time unit, not different units. But there again, as I've just mentioned, a number comes from a rate. Okay, a rate is really just a proportion. That's all a rate is. Okay, so a rate is a proportion. And it says this way of comparing two different units is termed a rate. That's absolute poppycock. It's nonsense. And of course, if you go to another site that says a ratio indicates a relationship of one thing to another, that's correct. Or indicates that we are comparing the number of one thing to the number of another, that's not true, because that is called quotientness, or finding the measure of something. And it says it's usually written as two numbers. Actually, it's usually not written as two numbers, but as two magnitudes, which are not numbers. Okay, like I've just shown you here. It's usually written as either two line segments or two masses, or two areas. Okay? That's the original definition of ratio, not numbers. So I want to recommend my article to you, What Exactly is Rate? And please, you need to study this article to understand it. You will understand better than you've understood in all your life if you study this article, because it tells you how we got numbers. Okay. It tells you not only how we got numbers, it explains what is a ratio, what is a rate, and why are these things important? Because you use them in every aspect of your physical life. Okay. You use them in every STEM field, in every field that matters. Okay. Even in things like preparing food or medicine. Okay. And ratio, by the way, comes up in every single STEM concept: slope, length, angle, derivative, probability. Everything is really number. Whoever said that was actually quite a wise person. Everything is number. And we don't invent number, we realize the concept of number. So this is a good article. And also another good article is How We Got Numbers, and I'll place a link to that too. If you're not already a subscriber, become one. My name's John Gabriel. This is a new calculus channel. Don't forget to click like. Till next time, goodbye.